Chandrayaan-3 was launched on 14th July 2023. In this video, we will look into the parts of Chandrayaan-3 rocket. Then we will see the complete journey of Chandrayaan-3 from Earth to Moon. This is the rocket that was launched. It is called as LVM3 M4. The expanded form for LVM3 is Launch Vehicle Mark III. This is the most powerful operational rocket built so far by ISRO. This rocket can carry objects weighing 4,000 kilograms to 10,000 kilograms. Now we will see what M4 is. M4 represents mission 4, which means that this is the fourth mission using LVM3 rocket. Now we will look into the parts of the rocket. The rockets in the two sides are called as S200. These are called as solid rocket boosters. These rockets makes it possible to push the entire rocket against the Earth's gravity and move up. These rockets contain solid fuel, hence it is called as solid rocket boosters. The rocket in between is called as L110. This is called as liquid stage. L110 contains liquid fuel, hence it is called as liquid stage. The section above L110 is C25. It is called as cryogenic stage. As the rocket goes into higher altitude, the temperature reduces. The fuel in C25 makes it possible to ignite in cold conditions, hence it is called as cryogenic stage. The top section of rocket contains the payload. What we want to send to the space is what should be present in this section. If we want to send satellites, then this section should have satellites. If we want to send humans, then this section should have humans. For this Chandrayaan-3 mission, whatever needs to be sent to the moon should be present here. The objective of Chandrayaan-3 mission is to land a rover on moon and perform some research on its surface. For the rover to land in the moon, we need the lander module. To take the lander module to moon, we need the propulsion module. The rover will be inside the lander module. Lander module will be attached over the propulsion module, and all these parts put together is called as integrated module. This integrated module is what will be in the payload. So far we have seen all the main parts of the Chandrayaan-3 rocket. Moon is 384,000 or 384,000 kilometers away from Earth. Now we will see how this rocket reaches the moon from Earth. If an object is taken to an altitude of 160 kilometers from Earth's surface, it does not fall towards the Earth. That object will start revolving around the Earth. We call this as an orbit. All space missions' first objective is to reach beyond the 160 kilometers altitude. Now we will see how Chandrayaan-3 rocket reaches the orbit from Earth's surface. The rocket is launched with the burning of S200 rockets on both sides. The solid fuel in S200 is ignited and it pushes the rocket up. At 108th second, L110 is also ignited. The rocket would now have reached 44 km in altitude. By 127th second, the S200 engines gets stopped when all fuel is burnt, then both the S200s are separated. Now the altitude is 62 km. By 194th second, the part covering the payload is removed, altitude 144 km. By 305th second, L110 is stopped and separated, altitude 175 km. By 307th second, C25 is ignited, altitude 176 km. By 954th second, C25 engine is stopped, altitude 174 km. By 969th second, C25 engine is separated, altitude 179 km. All these events happens in around 16 minutes and 179 km altitude is reached. Now propulsion module attached to lander module are the leftover parts. We already know that these two parts put together is called as integrated module. Going forward, integrated module is what is going to travel till the moon. Now the integrated module is traveling at a speed of 10 km per second. Imagine how much distance is 10 kilometers. If an integrated module travels at a speed of 10 km per second, you can guess the kind of speed it is currently traveling. Now no engines are ignited, then how is integrated module traveling at this speed? The reason is that the integrated module has started revolving around the Earth's orbit. The integrated module is currently traveling in high speed primarily because of its revolution in Earth's orbit. Now we will get to know more about orbit. Planets revolving the sun revolves in elliptical orbit and not in a circular orbit. The moon as well revolves in an elliptical orbit around the Earth. Another important aspect is that whichever object that is being orbited will not be in the center of the ellipse. Instead, it will be inclined towards the tip of the ellipse. By nature, planets, moons of planets revolve in an elliptical orbit. Due to this nature, the integrated module as well is going to revolve around the Earth in an elliptical path. The distance to reach Moon is 3,84,000 kilometers, of which so far we have covered only 179 kilometers. Currently, all our major engines and rocket power is gone. There is limited fuel available in propulsion module. With this, how are we going to reach the rest of 3,83,821 kilometers? This is where Orbit is going to come to our help. The integrated module is currently revolving in an elliptical orbit. As mentioned already, the Earth will not be in the center of the elliptical orbit and it is going to be towards a corner within the elliptical orbit. Due to this, the integrated module, when revolving around the Earth, it is going to come closer to the Earth and then it is going to go far away from the Earth. This is how the integrated module is going to continuously revolve around the Earth. When the integrated module is at the farthest distance from Earth, it is called as apogee. When the integrated module is at the nearest distance from Earth, it is called as perigee. Chandrayaan-3 was launched on July 14th. The next day, on July 15th, the apogee is 41,762 kilometers and the perigee is 173 kilometers. Without spending any fuel, we can see that the integrated module is able to travel 41,762 kilometers away from Earth. The orbit in which the integrated module currently revolving is called as lower Earth orbit. In short, this orbit is called as LEO. Any object revolving in this orbit would revolve the Earth 11 times each Earth day. On July 18th, when the integrated module came near the Earth, the propulsion module is given a boost from ISRO engineers for a short time. Due to this maneuver, the integrated module gets deviated away from the current orbit. Now the elliptical orbit becomes larger and it reaches 51,400 kilometers apogee. With very less fuel burned, we can see the integrated module has additionally traveled 10,000 kilometers. ISRO has defined a periodic schedule to do this maneuver every 2 to 3 days. Subsequent maneuvers like this are performed when the integrated module is in perigee or apogee. Totally 5 maneuvers are performed. The 6th maneuver is a longer one which places the integrated module in Moon's orbit and it is called as trans-lunar injection. This places the integrated module in Moon's orbit by 5th of August. Similar to the gravity of Earth, Moon has a gravity. Due to Moon's gravity, the integrated module is pulled into Moon's orbit and it starts revolving in the Moon's orbit. Now, the propulsion module is ignited to push the integrated module towards the Moon's surface. This gradually pushes the integrated module towards the Moon's surface. This push towards the Moon's surface is done 5 times and finally the orbit gets reduced to 100 kilometers. The 100 kilometer orbit of Moon is a circular orbit and not an elliptical orbit. We already know that the integrated module contains the propulsion module and lander module. The propulsion module has taken care of the journey from Earth's orbit till the 100 kilometer orbit of the Moon. The journey responsibility of propulsion module ends here. The further journey has to be accomplished by the lander module. Hence, the propulsion module is separated from the lander module. Now, the engines below the lander module pushes the lander module towards the Moon's surface. This makes the lander module to gradually get closer to the Moon's surface. In the meantime, the propulsion module continues to revolve around the Moon in the 100 kilometer orbit. The propulsion module conducts some research, takes photographs of Moon's surface and sends those details to IDSN. The expanded form for IDSN is Indian Deep Space Network, which is one of the base stations of ISRO in Bengaluru. The information from propulsion module is continuously sent to IDSN. When the lander module nears the Moon's surface, the lander module is made into a vertical position. Now, the engines below the lander module should take care of making a safe landing of lander module. During the earlier Chandrayaan-2 mission, this is when it failed and the lander module crashed into the Moon's surface. It is expected that the lander module should land on Moon's surface by 23rd August. Once the lander module is landed on Moon's surface, the door in the lander module opens and a slide comes down. Rover slides through this and gets to the Moon's surface. Rover performs research on the surface of Moon and sends the details to lander module. The lander module propagates the information to propulsion module, which transmits the data to IDSN. When this data transmission happens, the mission becomes a success. After end of this mission, propulsion module continues to orbit the Moon. Lander module remains in the place where it landed. Rover remains in the place once its functions stop. Bringing back propulsion module, lander module and rover is not part of this mission. We all are excited to have a successful completion of this mission on 23rd August. Hope this video helped you understand about Chandrayaan-3 mission journey. Thank you.